In our last examples, we're going to go back to function notation because you might be asked these questions related to two functions. So say I have f of x equals 1/4 x squared minus 3x minus 8, and I define g of x as x plus 12. Let's say we want to solve when the two functions are equal, or when one function is greater than or equal to the other or less than the other. So we can create function equations or function inequalities and solve them the same way we've been doing this. So let's go ahead to Desmos and take a look at what we would have. So here's Desmos. Let's enter these equations in ourselves. So f of x equals 1/4 x squared minus 3x minus 8. Now, one thing you'll notice is that we're not seeing very much of this graph. It should be a quadratic, but we're not really seeing much of it. We're going to need to adjust the window, but let me go ahead and put in the function g. This is something that's pretty typical that will happen, is that you'll have to adjust your window in Desmos. So the other thing I wanted to do with this example is really show adjusting your window. One thing to note about having higher exponents in your functions is that it's going to be a good idea sometimes to have a different scale on your x-axis compared to the y-axis. So instead of just zooming in, which you could do, zoom out or zoom in to get more of the graph, and that's not bad. You could probably see it all by moving it over. Sometimes it's useful to just use the graph settings instead, this little wrench symbol, because then you can keep your x values as is, but just expand your y values. So say we wanted to expand our y values instead of 23, let's go up to, say, 40. So if we now look at the graph, we can see exactly where the line and the parabola intersect. In fact, I'll go ahead and click on one of the graphs, and that will show me intersection points that I can click on and actually have those intersection values. Now let's take that picture back to our handout and evaluate it. So I've copied the graph back over into this document where I have the inequalities and equation that I want to solve. So first off, if I want to solve when the two functions are equal, that would be the intersection points, but in particular the x values of those intersection points. So we would want to go ahead and set up the solution set with those individual x values of -4 and 20. So my solution set for when the functions are equal to each other would just be those two values, -4 and 20. If I want to be greater than, so in this case f of x is greater than g of x, that's where the quadratic equation is above the linear equation. So look for where the quadratic or the parabola is above the line, and that would be in the two regions on the edges. So I would go ahead and show those regions as -infinity, because I'm going out to the left, up to -4. Because I can be equal with this inequality, I'm going to include the -4, and then the other region would start up at 20, including the 20, and go to infinity. So my solution set for when f is greater or equal to g would be the x values -infinity to -4, including the -4, and then 20 to infinity, including the 20. Finally, when we look at f of x less than g of x, that would be when the graph of the parabola is underneath the graph of the line. So that would be in this region. So we'll be looking at values from -4 up to 20. And because I do not have an equal sign in the inequality, I would use a parentheses. So I end up with a solution set of -4 to 20 for my last result. So don't forget, you can check each of those. With an equation, you should get the same thing on both sides. With an inequality solution that you check, you won't get that they're equal. You'll get that the value on the left is bigger than the right on this second one, and on the right, on the last one, you'll get that the right value is less than the left value. So don't forget to check as you go along.